So hello everyone. In today's class, we'll be looking at single-tailed hypothesis test. So before we go on to the single-tailed hypothesis test, we'll look at the two-tailed hypothesis test. In two-tailed hypothesis test, you always use equal to and not equal to while writing your null and your alternate hypothesis. In null hypothesis, the condition is that there is no difference. That means it is equal. So null hypothesis is always written as equal to. There is no difference or there is no increase, there is no decrease. Something which makes both the variables at equal level. And the alternate hypothesis will be the opposite of my null hypothesis. So when we are saying in null hypothesis that it is equal to, then in alternate it will be not equal to. So this is what we write for null hypothesis and alternate hypothesis. So when you use equal to symbol, now in a normal distribution curve, when you use equal to symbol, you see the mouth is open this side and it is also open this side. So that is why we have a rejection region over here and we also have a rejection region over here, this side. So on both these sides, we have rejection region. Now, in single-tailed hypothesis test, what happens is that the rejection region will either be on the left-hand side or it will be on the right-hand side. So, it will not be on both the sides of the normal distribution curve. So now how do we write a single-tailed hypothesis test? There are two cases. The first case is this one. That is when the rejection region is on the left-hand side. So an easy way to remember is when you write greater than and when you write less than symbol, you should see which side the mouth is opening for greater than symbol and which side the mouth is opening for less than symbol. Now when you write greater than symbol, the mouth is opening this side, which means the rejection region will fall on the left hand side. When you write less than, the mouth is opening towards the right. So the rejection region will lie towards the right. So in a similar manner, if you see over here, if I draw less than or equal to for the null hypothesis, since we have it over here, the mouth is opening towards the left and so the rejection region is towards the left. And a single tail hypothesis, the second case is where you'll use less than or equal to. So less than or equal to, the mouth is opening towards the right and we have the rejection region towards the right. So this is how you know in a single tailed hypothesis test which side, that is whether it is the rejection region is towards the left hand side or is it towards the right hand side by seeing the symbol that you have used in the null hypothesis. So this is just a summary of how you write the hypothesis for all the three cases. So when the rejection region is on the left hand side, you will use your null hypothesis as mu is greater than or equal to the value which is given in the question. And the alternate is just the opposite. So since we have three symbols, greater than, equal to and less than, and we have already used these two symbols, so the remaining is less than, so that we use for writing my alternate hypothesis in the very first case. So when we draw a diagram like this, the rejection region is on the left hand side. That means the rejection region is towards this side. And then when we see the second case where the rejection region is towards the right hand side, so if we draw like this again, the rejection region is towards the right hand side. So this side we have the rejection region, and since we will write the null hypothesis as less than or equal to, where less than or equal to, the mouth is opening towards the right hand side, and we have rejection region on the right hand side. Now since we have used less than and equal to, the only option which is left is greater than. So that we use for writing my alternate hypothesis. And the last case is the two-tailed hypothesis test, where you write your null hypothesis is mu is equal to, and the opposite is it is not equal to. So this is how you write the hypothesis in all the three cases. So there are certain guidelines while you write your null hypothesis. Null hypothesis should not have strict inequality. That is, it cannot have not equal to, greater than, or less than symbol. So these three symbols you cannot use while writing your null hypothesis. You can use all these three symbols for writing your null hypothesis: equal to, less than equal to, and greater than or equal to. So these three symbols only you need to use while you're writing your null hypothesis. And below this slide we have, for different types of tests, what your null hypothesis contains, number of rejection regions, and the cutoff value, how it will be calculated. T-statistic value will be calculated using this formula. There will be a slight change in calculating your T cutoff. So for two-tailed tests, your null hypothesis will always contain equal to, rejection region are on both the side, left and right, and here cutoff value will be plus or minus modulus of T dot inv alpha by 2 comma degrees of freedom n minus 1. Whereas for one-tailed test, where the rejection region is towards the left hand side, you will use greater than or equal to. So the rejection region is on the left hand side, and here your cutoff value is minus T dot inv alpha. Since the rejection region is just on one side, we do not write alpha by 2. We do not write this. We only write alpha comma n minus 1. And the next one is one-tailed test on the right hand side. So we write less than or equal to, number of rejection region is 1 on the right hand side, and the cutoff value will be calculated using plus T dot inv alpha comma n minus 1. So this is how you actually calculate your cutoff value and know how many rejection regions you have, and the symbols that you will use for writing your hypothesis. So moving on to the Excel file, where we'll see two examples. So the first example is, we're going to take the airline Comfyflight data, which is claiming that their average flight delay is less than and equal to 20 minutes. Perform a hypothesis test on this claim. So if nothing is given, you will assume your alpha as 0.05. So now we have, if you see, the airline data has three sets of flights: Comfyflight, EasyJet, and FastAir. Since we are only interested in Comfyflight, we have selected the Comfyflight data, and now we have to calculate a few values like the X bar and the standard deviation, and we also need to know the N value, how many records we have for the Comfyflight. So first of all, let's see how many records we have. So if we just select and see, we have 79 records. So that is how we get the value of N, which is 79. Then the next one is X bar. X bar is nothing but, you need to calculate the average of the time delay column. Why time delay? Because it is saying the average flight delay. So we are only interested in the time delay column. So that is why we just need to like put the formula as average of all the values of time delay for ComfyFlight. So we have till 210. So this is what is being visible over here, and click on enter. You will get the value as 28.05. Now the next one is the standard deviation. Standard deviation also we will be finding out for the data that we have. So again, stdev.s, because this is just a sample of all the ComfyFlight or the flights that are operated by ComfyFlight. So it's stdev.s and the time delay, all the time delay of ComfyFlight. And when you click, you get 28.15. So these are the calculation that you need to do. Then after that, you need to see what is your mu value. This mu value, which is 20, is got from the question, which is less than or equal to 20 minutes. So this 20 minutes is my mu value. With the help of this only, we will write our hypothesis. So now, if you see how do we write the hypothesis, the flight delay is less than or equal to 20 minutes. So now this is the information that we have from the question. So the null hypothesis is the population mean. Null hypothesis and alternate hypothesis are always framed for the population mean and not for the population standard deviation or sample mean or sample standard deviation. It is only for the population mean. So null hypothesis is population mean is now less than or equal to 20. So that is what I have written over here. Now since we have already used less than and equal to, the only symbol that is left is greater than, and we write that in the alternate hypothesis. So after calculation of your x bar, n, mu and s, you will write your hypothesis, your null and your alternate hypothesis. Once this is done, you need to calculate your t-stat value. Now t-stat value can easily be calculated using x bar minus mu by standard deviation by square root of n. So when you do that, you get your t-stat value. That is what I have written over here in the formula. Click on enter and you get 2.542 as the value. After calculation of t-stat, you need to calculate your t cutoff value. T cutoff value is absolute of t dot inv 0.05, because here you can see the rejection region is, since we have used less than or equal to, the mouth is opening towards the right hand side. So therefore the rejection region is on the right hand side. So therefore t cutoff value is plus modulus of t dot inv alpha comma degrees of freedom. So that same thing we have written over here, plus absolute of t dot inv 0.05 comma the degrees of freedom, which is nothing but 79 minus 1, 78. Click on enter, you get the value of t cutoff as 1.6646. Now after finding this t-stat and t cutoff value, you need to draw a normal distribution curve and plot these two values. So now the t cutoff value is, for example, let us assume that it is this particular line. This is the line which is the t cutoff value. So towards the right of this particular point, 1.6646, our rejection region will lie. This towards the left of this particular point is our acceptance region. So in order to accept a null hypothesis, our t statistic value should lie in this particular acceptance region. But if it falls in this particular rejection region, that is towards the right of 1.6646, then we will reject a null hypothesis. And in this case, since a t-stat is 2.542, our value will lies somewhere over here, 2.542, which means that it is falling in the rejection region. Since my t-stat value is falling in the rejection region, I will reject my null hypothesis and accept my alternate hypothesis. So what will be my interpretation? My interpretation will be that since my t-stat value lies in the rejection region, I will accept my alternate hypothesis, which means that the claim which is made by the Comfy flight is not true, because Comfy flight is assuming that it is having an average flight delay of less than or equal to 20 minutes, which we have rejected. So the claim made by the Comfy flight is not true, since we accept the alternate hypothesis. So the same question can be asked as the Comfy flight advertises that the average flight delay is more than and equal to 20 minutes. In that case, we will be writing our, if it is more than and equal to 20 minutes, in this case, the null hypothesis will be mu is greater than or equal to 20 minutes, and my alternate hypothesis will be mu is less than 20 minutes. So you can get questions as less than and equal to or more than and equal to. There is one special case where you will be sometimes given the question as for example, EasyJet advertises that their average flight delay is less than 20 minutes, which means when you write the null hypothesis, you write mu is less than 20 minutes, and the alternate as mu is greater than or equal to 20 minutes. But if you see the null hypothesis, this is not as per the guidelines that we have seen. Our null hypothesis should not have strict inequality. So not equal to, less than, greater than, these cannot be used in my null hypothesis. So this one doesn't adhere to the conditions which I have. So what I do is I'm going to just swap or interchange my null and my alternate hypothesis in this case. So now when I swap it, this one becomes my null hypothesis and this becomes my alternate hypothesis. So this is the new hypothesis that I have. So now my new hypothesis is, null hypothesis is mu is greater than or equal to 20 and mu is less than 20. Now again we need to calculate the x bar, that is the average of all the values of time delay for EasyJet. Then the standard deviation, mu is, since we have 20 minutes, so mu is 20. N is count how many values you have over here, and we have around 61 rows of values, so N is 61. Once you get all these information, calculate your t-statistic value using the formula of x bar minus mu by standard deviation by square root of n. You get the value as minus 1.022. Since you see that in the new null hypothesis, our mouth is opening towards the left hand side, our t cutoff value will be minus absolute of t dot inv 0.05, degrees of freedom. And when you click on the value, you get minus 1.6706. Now, after you get your t-stat and your t-cutoff, plot this value over here in the diagram of a normal distribution curve. You see that the t-cutoff is minus 6.706, which is somewhere over here. towards the left of that particular point of minus 1.6706, we have the rejection region. Now we have to see where our t-stat value falls. Our t-stat value is basically this orange line, which is minus 1.022. So this orange line is falling in the white region, which is the acceptance region. That is the region which is towards the right of minus 1.6706. Since this t-stat minus 1.022 falls in the white or the acceptance region, we will accept our null hypothesis. So we are accepting this particular hypothesis and rejecting this alternate hypothesis. Now our interpretation will be, since our t-stat value minus 1.022 lies in the acceptance region, we accept our null hypothesis, which states that the population mean or the average flight delay is greater than or equal to 20 minutes. So the claim made by the EasyJet, which is the average flight delay is less than 20 minutes, is not true. It is false. So this is the whole interpretation that you have for this particular problem. So I hope you have understood how you write your null and alternate hypothesis when it is mentioned less than 20 minutes. The same case will be applicable when you have a question of more than 20 minutes. So here now the null hypothesis and the alternate hypothesis. So more than 20 minutes, so we will write mu is greater than 20 minutes and our alternate is mu is less than or equal to 20 minutes. But this alternate which I have, null hypothesis which I have written, is not as per the criteria or the conditions which we have. Therefore, we swap these two and we make our new hypothesis as mu is less than or equal to 20 minutes and alternate as mu is greater than 20 minutes. So this gets removed and changed to this one. So this is our null hypothesis and this is our alternate hypothesis. Again, we do the calculation for t-stat, t-cutoff, and either accept the null hypothesis or reject my null hypothesis, accepting our alternate hypothesis. So this is how you do for all these four cases of less than and equal to, more than and equal to, and also for the case of less than and more than. So these are all the varieties of single-tailed hypothesis test.